My name is Melissa Moreno, and my presentation is on my first chapter of my thesis, Big Changes in the Big Bend, a Data Management Story. I would like to thank SNRE, also the UF Academic Research Consulting Services, and WEC. So the problem, we have an oyster restoration site that we built to historical elevation levels, and we wanted to measure water quality around the reef near the landward side and the seaward side. So we have currently 11 sites out there. I know there's not as many in this picture, but those are new sites. And they record water quality like salinity, temperature, and conductivity on the hour once every hour. So at the end of the month, we have thousands of observations, and we wanted to go ahead and keep a record of where and what sensors are in what fixed located site. So we wanted to design a database or a storage system so that we are able to track these changes. So the solution that we came up with, the library team, as mentioned earlier, is to create a custom MySQL database, and every table is going to be related to a sensor's location and a sensor site. So there's no way that we can import or download these observations into the database without knowing these things beforehand. So things that we need to know beforehand are which specific sensor is in which specific location, and when does that change, and when we are going to change that, because let's say of maintenance on the sensor or the sensor gets lost, how to allocate for that. So within our database, in our sensor deploy table, we are able to say when a sensor is active at a specific site, basically using some, not commands, but using a check-in and check-out and check-in procedure. Once a sensor is checked out of a site, we could put a new sensor in the site that it was currently, if we need to switch out a sensor. So we have these, we store water quality in specific tables where the sensor serial number and location must be predefined. And this is where the field team and the data management team have to work hand in hand, because we have to know what is actually going on in the field so this database can work. In the field, in step 2, they download the field water quality site. In step 3, in the lab, we use a custom Python import process to download, or to import these observations into MySQL. We keep all observations, whether they are corrupt or look a little off, in the MySQL database if we ever want to refer to them, and we do any kind of like cleaning or checking inside of R, and that's more of a virtual environment. Then we store everything in GitHub. The conclusion to my first chapter thesis is to work with your PI team members and specialists to come up with the best way to manage your specific ecological data prior to field collection. Make sure you create, document, and train members on using the workflow, and communication with the team is key, especially when you're dealing with so many team members in the field, team members in the lab. So a lot of our work that we first were doing was actually just theorizing the workflow, what we wanted it to be like. And because of that, we have been able to store, I don't know how many observations, but now it must be tens of thousands of observations. And we know from which site they are at what specific time and what sensor was collecting it for any given site. So it's been a pretty big success on our part in at least tracking the water quality data that is coming from those sensors. And I hope that this presentation gives you kind of inspiration before you go out to collect your field data on how you would like to manage it, because that is a huge component of ecological data sampling. Thank you.